So hi everyone. So today we are going to discuss about dynamic routing protocols. Again, you can see dynamic routing protocols is a part of routing technologies. So where you will configure the routing protocols? Can anyone tell me?
L3 devices,
Yeah. What do you mean by L3 devices?
routers.
Yes, routers. You can see these are the different types of routers. So I will show you these images every day because you will familiar with the routers. This is a routers, small router, big router, medium router kind of routers. So different company. This is Cisco router here. These are the Juniper routers. Okay. So you will configure routing protocols on layer 3 devices called routers. So today I'm going to discuss about dynamic routing protocols. Okay. I just want to tell you one procedure, brother. If you want to book if you want to go any location, you will book the train or bus or aeroplane, yes or no, to travel it, right? So what is the process? You can open any Paytm or Abibus, any third party app. You will open it and you will give the destination and you will book the tickets. That is a general process. Once you book the ticket, you will go to the bus stand or airport or wherever it is, and you will show the ticket and you will travel it. What is this? This is a default procedure to travel from one location to another location. Similarly, for dynamic routing protocols, there are 3 to 4 dynamic routing protocols. You can say widely they are using 3 dynamic routing protocols. One is OSPF, ISIS, EIGRP, and BGP as well. BGP, in dynamic routing protocols, there are depends on the usage. We will have a different routing protocols. Okay, all these routing protocols have the same procedure. Okay, maybe the way we travel is different. We can go via bus or train or airplane, right? Similarly, the routing protocol, uh, uh, you know, the working procedure may be different, but the behavior is same. So I want to explain you the overall behavior so that you can easily familiar with the protocols. So I'm going to deeply explain about OSPF. See guys, my teaching style is different. So whatever they are using in real time, do you want me to explain that protocol completely or do you want me to cover all the protocols as per the syllabus? As per the syllabus, EHRP and OSPF is there. These are the 2 dynamic routing protocols as per the CCNA syllabus. But if I am teaching right, as per the syllabus, very few information I can teach. Or else you can choose one protocol which is used in real time widely 90%, and I want to dig more and I want to explain that protocol at CCIE level. In which way you want to learn? Please let me know. Do you want
Yeah,
so
the second one is better.
deeply you want
So,
to learn, right?
yeah,
Everyone agree? Please.
Yes, sir.
Right.
Yes, sir.
So, however, I also teach EHRP, but I cannot explain that much deep. However, once you learn the OSPF, it's the same process, same thing, only few thing is different, algorithm is different, 10% is different. The 10% I will explain it so that I will cover both. Okay, right? Let's do this. So let me explain dynamic routing protocols behavior. Here, the static routing disadvantage is you need to add the routes manually in routing table. Yes or no? Right?
Yes, sir.
Right?
yes,
So
sir.
let me take example. Open a project. OSPF. Okay, perfect, brothers. Okay, let me take an example, real-time example. So this is an example, right? Same thing. So let me take a new project. I want to take a new project, OSPF D6. Okay. So suppose I'm using 3 routers here. You know it very well. So fresh project I have taken here. Guys, you have time, right? So anyone having any uh appointments like The class will go till 8:40, 8:50. That is fine, right, with you? Okay.
Yes, bro.
Fine, sir.
Okay. Error creating a link port is already being used. Okay. What port is already being used, brother? Let's see. 3/0. Okay. Okay. Fine. Cool. Perfect. So this is a connection. I can consider R1 IP address is 1.1.1. Okay. R2 IP address is 2.2.2. Listen carefully. I'm teaching concept. Okay. This concept, some of the things will not there in internet to understand easily. Okay. Yeah. These are the three routers. See, if I want to ping 3.3.3, will it ping? No, because you don't see any route in routing table generally, right? You don't see any route in routing table. This is a 12.0 network, right? 12.0 slash 24. This is which network? 23.0 slash 24. Okay, simple. So the thing is, if you want to ping from 1.1 to 3.3, you cannot ping because there is no route in routing table. What you need to do, you need to add the routes. The 3.3.3 route should be there in R1's routing table. If it should be there, what we have done is last time we did manually, we added the route manually. How we added the route manually? IP route, so 3.3.3.3 and that subnet mask and the gateway is 192.168.12.2. Like this we have configured. Yes or no, everyone, right? This is a static route we have done. How, see, the disadvantage of static route is you need to add these routes manually in your routing table. To add these routes in manually in routing table, you should know the topology, the network, the subnet mask, and the gateway. Okay. So if it is a big network, if you have 1,000 routers, how can you add these 1,000 routes manually into the routing table, right? That's why. Also, one more disadvantage is like this. So for reverse path, right, you may see the asymmetric routings for multiple path. You cannot implement static route for multiple path, right? So just now Kailash is highlighted that. So if you give a in reverse path, it cannot possible. It is not pinging because we shut down the link. So how can it choose, right? So that's the problem here, static route. That's why we use dynamic routing protocols. What dynamic routing protocols will do? It will learn the routes automatically. How it will run the routes? So dynamic routing protocols, exactly how it behaves, I'll tell you here. So how it will behave? See how it will behave. So the basic procedure, right? So how you book the ticket, how you will travel, same thing. I'm explaining about dynamic routing protocols behavior. So once you configure a dynamic routing protocol on the both the devices, like here, once you configure a dynamic routing protocols on both the routers, suppose on R1 and R2, I have configured a dynamic routing protocol, whatever it is. So dynamic routing protocols are two types. Okay, I'll tell you. So if you configure a dynamic routing protocols on R1 R2, what it will do? It will exchange a hello packets. Suppose my name is Ramesh and Kailash is there. Me and Kailash had a connection, dynamic routing protocol connection. I said, hello Kailash. Kailash said, hello Ramesh. Now we both discovered as a neighbors. We are the neighbors. Okay. My neighbor is Kailash, Kailash neighbor is me. And then once we discover the neighbors, we establish a neighborship. And then what we'll do, whatever the information is there in my mind, I will explain to Kailash. Kailash also, whatever his information having his mind, right? The connections which is having, he's exchanging that information to me so that what the databases, my database and Kailash database, both will exchange each other. So simple. Okay. After exchanging the database, then we will calculate a best paths. Okay. To reach the destination, what is the best path? Okay. So it will use a algorithm, special algorithm. Each and every protocol uses a algorithm. Based on the algorithm, we will choose the best path. Okay. So again, I'm telling you how dynamic routing protocols will work. First, once you configure the dynamic routing protocol, first they will discover the neighbors. After that, they will exchange the routes, whatever the routes is there, right? Suppose I have configured dynamic routing protocol on R1 and R2. They will discover the neighbors. Then they will exchange their routes 2.2.2, 1.1.1 automatically. After that, is there any connections, right? R2 having extra connections. So this route also it will advertise automatically. How many routers are there doesn't matter. All the routers should configure one dynamic routing protocol. So there are different dynamic routing protocols. You have to use one dynamic routing protocol on all the routers. Then only the routes will be exchanged. Okay. Suppose between R1 and R2 you have configured OSPF, R2, R3 you have configured EIGRP. So this is one protocol, this is different protocol. So you cannot see 3.3.3 in here. Okay. So that concept is different. I'll explain you later. So redistribution will come when you want to distribute EHRP to OSPF, OSPF to EHRP. Anyhow, so the thing is, see here carefully. First, so they will discover the neighbors, then they will advertise the routes, then based on the algorithm, they will choose the best path. Then all the best paths will be populated in routing table. After that, in case if anything happens, right? If the link is down or if anything happen, the routes will be withdrawn. Means if the link is down, whatever the routes in routing table, right, that will be removed. Okay, that's the thing. This is a process. They will discover the neighbors. After that, the routes will be advertised. Then it will use the algorithm to calculate the best paths. All the best paths will be populated in routing table. This is the process. Once it is done, right, in case if anything happen, new route is added or existing route is deleted, right? It means if any new another R4 router added, 4.4.4 is added, right? That route update will be updated in database. If any existing route is deleted, suppose 3.3.3 is deleted, that route will be deleted from the routing table accordingly. It means any topology changes are detected. Okay. Or if you made any changes, right, that will be done. Okay, through update messages. Okay, this is about dynamic routing protocols behavior. Okay, everyone understood? This is very important. This is a common process. If you remember this, you will easily understand each and every dynamic routing protocol. Okay, so the advantages, disadvantages of the dynamic routing protocol, you can learn it. Okay, so now they have divided dynamic routing protocols based on two ways, based on the autonomous system numbers. Okay, so what is that? IGP and EGP. Okay, suppose Airtel, Geo, Tifi, Tata Communications are there. They are having the Airtel is there in entire India, right? Entire India, the Airtel Geo is there. So how thousands of routers they are using? Okay, between the routers they are configuring a routing protocols. So within the Airtel, right, it's the same. So it is interior gateway protocol. They will use interior gateway protocol. So within the Geo, they will use interior gateway protocol. So the dynamic routing protocols are again divided into two ways. One is IGP, one is EGP. IGP in the sense, if you use the routing protocol within your company, within the autonomous system number. What do you mean by autonomous system number? In routing domain. In routing domain, it will represent your it represents uh, this is your property. It means autonomous system will have one number. That number is 2 power 16. It means 65,536 autonomous system numbers are there. Here also you will have private autonomous system numbers, public autonomous system numbers. So same, if you want to give a public ISP, right, you need to purchase from IANA. Okay. So the thing is, these are the autonomous system numbers. Each and every company will have a autonomous system numbers. Okay. The autonomous system numbers are 2 power 16. It means 65,536. 0 to 65,535. Okay, so 65,536 means 0 also need to include, right? If you include this 36 or else 0 to 535. And these are the public numbers 1 to 64,511. They might ask you in interview. Okay, what are the public autonomous system numbers? 1 to 64,511. And the private are rest 64,512 to 65,535. These are the autonomous system numbers. Autonomous system number in the sense each company will have a autonomous system number. You can also check, Google is there. What is the autonomous system number for Google? Let's check. What is the autonomous system for Google? See, these are the autonomous system numbers for Google. Each and every company will have a autonomous system number to represent their routing information. Okay, in everyone using routing protocols, right? They use routing protocols. Okay, so in their routing platform, you have to represent. Suppose Tungabhadra network is there. My branches are in Karnool and Hyderabad. To represent my company and my network in routing, especially routing domain, I should have a autonomous system number. Okay, service providers, whatever the service providers, Geo, Airtel, your local broadband connections as well are also having autonomous system numbers. Okay, so it is a logical representation in routing domain. Autonomous system number is a logical representation in routing domain. Autonomous system numbers, also known as a routing domains, are collection of routers under the same administration. It means in in India, Airtel is there. Whatever the routers you install and configure a routing protocols in India, in Airtel, you have one autonomous system number that belongs to Airtel. So based on the autonomous system numbers, we'll recognize this belongs to Airtel like that. Okay. Yeah. So if you configure a routing protocol within the autonomous system number, we use interior gateway protocol within the autonomous system number. So how many interior gateway protocols we have? Three interior gateway protocols we have. One is OSPF, ISIS, EIGRP. These are the main thing. OSPF and ISIS are link state database protocols. EIGRP is the distinct vector routing protocol. Okay. OSPF and ISIS both are same. The implementation only different. Okay. They use both same algorithm, OSPF and ISIS. This VHRP we use dual algorithm. Okay, fine. So these are the dynamic routing protocols. There is another routing protocol is called RIP. RIP is RIP, rest in peace. No one is using now. Okay, and the one exterior gateway protocol. So interior is within the autonomous system, but then exterior in the sense between the autonomous system members. It means, see, currently if you if you make a call from Geo to Airtel number, the call is going right. Yes or no? How it is possible? I'm using Airtel SIM, but I'm calling to the Geo phone number. How it is happening? I'm able to I'm able to call Geo phone number. How it is happening? Because between Airtel and Geo, they are configuring a routing protocol that is EGP. Geo is having one autonomous system number, Airtel is having another autonomous system number. Okay. So between them, they are configuring a protocol that is called EGP. We have only one routing protocol in EGP, that is BGP protocol, border gateway protocol. Border gateway protocol. Why we have only one routing protocol? Because in entire world we have lot of service providers, lot of companies, lot of autonomous system numbers. Each companies are connecting each other like this. That's how we are exchanging the interface in internet. All every service providers are connecting each other. Okay, so suppose this is Africa, right? It is having one autonomous system number. In Africa, whatever the data centers, right, all the data centers are connected to this service provider, and it is advertising to another. So all are connecting each other. That's why we are accessing the internet wherever, suppose we are watching border gateway border Gavaskar trophy, right? Indian versus Australia, it is happening here. How we are watching? They are connecting each other like this, right? So service providers are connecting each other and we are watching it. Okay. Yes, through under ocean cable they are connecting each other. They have autonomous system numbers. We configure BGP. That's why BGP we call internet. Okay, we have only one protocol. Why? The internet in entire world is already established. If you change the version, if you implement another protocol, your entire communication will gone. You cannot talk to anyone. That's why they're not touching the BGP. The BGP version is 4, still it's 4 only. They're not changing the version, they're not doing anything. They're just adding the capabilities, just adding the features in BGP. That's it. They're not changing this version. They're not even touching this BGP protocol. They implemented in long back, they're still using the same. because the internet is already established. Between the autonomous system numbers, you configure EGP. Within the autonomous system number, you configure IGP. What are the IGP protocols we have? OSPF, C, EIGRP, OSPF, and ISIS. These are the link state database routing protocols. What do you mean by link state? I will explain you tomorrow, theory. Okay. So EIGRP, Interior Enhanced Gateway Protocol. Interior Gateway Protocol. Actually, this is developed by Cisco. Okay. Till 2013, it was Cisco proprietary, but after 2013, any vendor can implement this algorithm. Anyone can implement this feature. But other vendors, Juniper and other vendors, they didn't implement it because we have OSPF. Why we need your EIGRP? If you implemented your feature, it will be famous, right? That's why they are not implemented. Only Arista companies implemented EIGRP. Okay. So other top vendors, Juniper, they're still using OSPF. Okay, it's a best protocol. We have a best protocol. Why we want to implement your protocol, right? The vendor, the competitor. Anyhow, people may ask you EIGRP also. So that's why I'm giving less preference to EIGRP. OSPF is the open standard protocol. I mean, what is that? It's a it's a as per RFC, it's a open standard protocol. Everyone can use it. Suppose I'm a Ramesh, I'm going to create a Ramesh router. I'm going to develop my own OS. So while developing, I need to follow the RFC and I need to develop OSPF in my operating system like that. Okay, that's it. So this is all about dynamic routing protocols, EGP, IGP, autonomous system number, and all. Any questions so far? If you clear right, I will start digging more about IGP as OSPF. I'll talk about OSPF. I'll do lab. I don't explain any theory today. I'll directly do lab. It's simple. Okay. So is it understandable what I am saying so far? Is it clear?
Bro, once explain with ASNs.
What is that? See, ask a question clearly. What you said? What do you say?
Once explain this ASNs.
Yes, sensor.
ASN, ASN.
He's asking about AS number, Anna. Can you
Autonomous
explain
system.
one more about AS? Ah,
Brother, you can you can abbreviate it, right? You want me to
he's
explain autonomous
asking
system?
about AS, Anna. What is the purpose of AS number, Anna? He's asking.
Okay. This is what AS number, brother. Each and every company maintains autonomous system number. Suppose what's your name? I don't see that. What's your name? Okay, fine. My name is Ramesh. I have my own service provider. Okay. Ramesh is having own service provider. I'm sitting in Kurnool. I'm giving internet connection to the Kurnool people. So I have my own autonomous system. I use routers, right? So in at every 30 kilometers, I install routers. I configure a routing protocol. So I need to represent my domain. It's a Ramesh network. How can you represent my Ramesh network in routing domain? That is called autonomous system number. Autonomous system number is representation for every company. Each and every company will have their own autonomous system number. They have to purchase it. Understood now?
Clear, bro, clear.
Right? So Adi. So that is the autonomous system number is just a representation in routing domain. In routing domain, you have to represent, right, where exactly you are coming from. So I'm coming from Kurnool. How you will come to know? So based on the autonomous system number, same. This autonomous system number is belong to this company. I told you right here. I did a Google search. What is the Google autonomous system numbers? These are the Google autonomous system numbers. If any route is coming and attached with autonomous system number, this is a Google route. You consider this as a Google route, and you can ask Airtel autonomous system number. Let's ask Airtel autonomous system number. So Airtel autonomous, what is that? 9498 is a Airtel autonomous system number. Clear? This is a Bharti Airtel autonomous HN. So I'm using DVR kernel internet. So this is DVR internet. Let's see what is the DVR autonomous system number. Let's check. I'm using local broadband connection. My local broadband connection also have one autonomous system number. It's loading. Let's see. Yeah, this is autonomous system number 141300303. Everyone understood? Every company, every service provider will have a autonomous system number. Who is providing internet services, right? Those. Clear, brother, about autonomous system number? Anyone having any issues? Any questions? No, right? Yeah. Okay. Now, yeah, please
బ్రో
continue.
అది
Hmm.
అల్గారిథం అని చెప్పారు కదా అది ఎలా వర్క్ అవుద్ది?
ఇంకా ఏ అల్గారిథం స్పెసిఫిక్ గా అల్గారిథం పేరు చెప్పలే కదా. ఓకే, జస్ట్ అల్గారిథం అనే అన్నా నేను. ఒక్కొక్క ప్రోటోకాల్ ఒక్కొక్క అల్గారిథం యూస్ చేస్తుంది. ఆ ప్రోటోకాల్ గురించి డిస్కస్ చేసినప్పుడు ఆ అల్గారిథం గురించి చెప్తా. ఓకేనా?
ఓకే ఓకే.
Okay. So now I'm going to discuss about OSPF. OSPF is a dynamic routing protocol. Okay. What it will do, if you configure a dynamic routing protocol, what it will do, it will discover the neighbors, then it will exchange the routes, then it will run the algorithm that is called Dijkstra algorithm. Then it will populate a routing table and put all the routes in routing table. Okay. This step-by-step explanation I will do tomorrow. Today I want to do the lab. By doing lab, you will come to know. So, shall we do yesterday lab or today lab? Okay, I'll do yesterday lab only. So, what I want to do, otherwise, you can do fresh lab. What you want me to do? So, what
Yeah,
you can
sir.
do
Fresh
is,
lab.
I'll do fresh lab. You can implement, you can remove static route in DICP. You did right, static route, that lab. So, remove static route from all R1, R2, R3 and configure OSPF and check it. So you can't see anything. You will not see any issues. Okay, let's configure OSPF. What is OSPF? OSPF is open shortest path protocol. It's a dynamic routing protocol. Okay, dynamic routing protocol. Okay, fine. So how you will configure this dynamic routing protocol? It's easy. Let's configure syntax. It's router OSPF. Go to the configuration mode. If you want to configure anything, you need to enter into the configuration mode. That is clear, right? Once you enter into the configuration mode, okay, router OSPF, and then give autonomous system number. How many autonomous system numbers we have? 65,535, right? You can give anything. Router OSPF, suppose I'm giving 10 is the autonomous system number. Okay, just random number. Okay, you can give anything between 0 to 65,535. Okay, router OSPF 10, then you will enter into the OSPF and then advertise your own networks. See, you have to advertise your networks, right? Then only, see, me and Kailash is connecting each other. I have to inform him what I know. Then only he will come to know, right? So R1 should advertise his networks to R2 in OSPF. Then only R2 will come to know. So what are the R1 routers? What are the R1 networks? Can anyone tell me what are the networks you will see in R1? So let me go on R1, check the routing table. So let's assign the IP address on R1, configure terminal, interface G1/0, no shutdown, IP address 192.168.12. What is that? 12.1 and subnet mask. Okay. Then interface loopback 0, IP address 1.1.1.1. Okay, that's it. So now check show IP route table. What are the networks you have? 1.1.1.1 and 12.0, right? You have two networks. 12.0 is one network, 1.1.1. So you have to advertise these two networks in OSPF. So dynamic routing protocol, how it works? You need to advertise yourself. So in OSPF, then only they will come to know, right? Rajamouli, he will take 4 years of time to, direct a movie. After that, he will do lot of advertisements, right? Like what Pushpa has done, lot of advertisements. So if you have a good product, you have to do advertisements. Even Mahesh Babu also do advertisements, right? For thumbs up and other thing. They're promoting their brand. I also telling you, you have a skills, you need to advertise yourself, show your skills on LinkedIn, right? Same thing. This R1 should advertise his routes, where he's advertising in OSPF. Then only here also you're configuring OSPF, they will come to know each other, then they will ping each other. Let's see. How to advertise the network? You need to give network. What are the network it is? 192.168.12.0. And now you need to give wildcard mask.
Wildcard mask.
Yes. So you need to give wildcard mask here. What is a wildcard mask? So
Total subnet mask, no,
yes, total subnet mask minus
our actual subnet mask.
actual subnet mask. So it will give you Wildcard mask. Why we using wildcard mask here? You're precisely matching these bits, last octet bits. So to you're matching octets precisely. You are only allowing these bits. So this is very precise information we are giving by using wildcard mask. Okay. So you need to give wildcard mask here. What is the wildcard mask here? 0.0.0.255. And now in OSPF we are using areas. What do you mean by area? I will give you one example. Suppose there is a delivery boy. Okay. There is a delivery boy. What the hell? Why? Oh, me. Okay. So there is a delivery boy. Okay. There is no, suppose in Hyderabad, there are lot of areas. If there is no areas, the delivery boy should, deliver the products in each and every customer. One delivery boy cannot do that. So that we have areas like Gachibowli area, Miapur area, okay, Charminar area, like that. Each area, different employee will travel and he will deliver, right? By creating areas, you can reduce the work, administrative work, and you can deliver all the data, all the parcels in one day. Okay. So here also in OSPF, we are using areas. Why we are using areas here? Because in OSPF, it's a link state database. Link state database. OSPF is a link state database. It means me and Kailash is there. We both are configured OSPF. So whatever the information I know, right? The same information will be there in Kailash mind as well. Okay. It means whatever the information I have R1 router. The same database, same routing table, same database, OSPF will be there in R2, will be there in R3 as well in the area. So that's why why we use areas, I will explain you tomorrow. But now simple remember, we use areas here. Why? To deliver the packets more efficiently. Okay. So exactly the real time example I will give you tomorrow. Real time example. Okay. Because there is a big explanation. To understand a small topic, I'm going to give a big explanation. Today, it is not a good day. I mean, we don't have a time to discuss about it, right? We will just configure how OSPF works. We'll just, we will do ping and we'll just see that and let's see how it works. Okay. That's it. Okay. Tomorrow we'll discuss only theory. Today we'll do lab. Okay, fine. So this is a network, and what you have to give, it's a area zero. You can give this is a area zero. All three routers belongs to area zero. So we call area zero as a backbone area. Why we need areas in OSPF? Why we call the area as a backbone area? It's a very big interview questions which you have to explain clearly. Simply, you should not give bookish knowledge. Why we call areas as a backbone area? It means it avoids the loops. How it will avoid the loops? No one can tell it. So that requires packet level explanation. So once you step by step, I design this OSPF, then we will learn each and everything. Okay, cool. So you have to give area zero. This is the command. This is a syntax to configure OSPF. There is another network. What is that? Can anyone tell me? We need to advertise one more network on R1. What is that?
1.1.1.1.
Where 1.1.1 precisely 0.0.0. Wildcard mask is 255, 255, 255, right? So, and what is that? Area 0. So this is it. So shall we configure OSPF quickly? Everyone. So R1, let's go config terminal. Can anyone help me with the commands? I need to configure OSPF.
Router
Router,
OSPF
Okay, router
OSPF.
OSPF. Let me give question
process
mark.
ID 10.
Yeah, it means this is autonomous system number. Process ID means autonomous system number. So you can give anything. Whatever you give autonomous system number, right? That should be same in entire OSPF. Okay. What I have taken here 10. So then after you need to advertise the routes. 192.168.12.0. and the sub
G.
wildcard mask, and you need to give area. Orini. Area 0. Next ఏంటి? Next, what network you want to
1.1.1.
advertise? Yes, 1.1.1.1 and then 0 area. So this is a, so if you want to see the configuration, right? Do show run section OSPF. If you want to see the only OSPF configuration, do this. So what is the OSPF configuration I've done? This is the thing. 12.0 network, and oh my god, this I have to remove. I wrongly configured this. Okay. What network you need to configure? Network 1.1.1.1 and the
అన్న
wildcard mask.
తప్పుది రిమూవ్ చేశారన్న పైది రిమూవ్ చేయాలని.
Ah, you're right, Macha. 1 second. ఇది మళ్ళీ కాన్ఫిగర్ చేస్తా. ఓకే. ఇది రిమూవ్ చేద్దాం పైది. Yes, you're right. So let me check. Do show run section OSPF. See, now I have advertised 1.1.1 network, and after the 12.0 network, I have advertised in OSPF. Now you see show IP OSPF neighbor. The neighbors is not established because I haven't configured OSPF on R2. Let's configure OSPF on R2. Okay. Tell me with the commands. First, I need to assign the IP addresses on the interface. So what is the interface here? Interface G1/0. Come on, guys. Active layer asalu. Please be active. And
192.168.223.0.
okay, okay. What is the loopback IP I'm taking? This is the one. Okay.
Two.
So just watch it and let me know if I'm doing anything wrong. Okay. Uh, 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 I interface. Oh, okay. Interface loopback 0. IP address. What happening here? Okay, done. Then interface G3/0. Everyone understood, right? What I'm doing? 23.2. I'm just assigning the IP address here and no shutdown. Show IP interface brief. See, I have assigning IP addresses on the interfaces. Perfect. Loopback also done. Now I need to configure OSPF. So router, what is a router? OSPF 10. So tell me the networks which I would like to advertise in OSPF. What is the networks? What are the networks?
12.0, 23.0, 2.2.2.
Very good. 12.0 and the wildcard mask with area 0. Then what is that? 23.0. See, OSPF is coming up. Then network 2.2.2.2 and wildcard mask and area 0. Perfect. So now see, show IP OSPF neighbors. See, one neighbor is discovered and established. Only between R1. R1 and R2 I have configured OSPF, it's up. But I have didn't configure on R3, right? Let's see. See, config terminal, router, OSPF 10. Oh, no, no, no. I need to assign the IP addresses first. Interface G 3/0. Okay. No shared. Okay, it's 3.3.3. IP add. Okay. Now router OSPF. Okay. See, doing lab is very easy, and you can do half an hour. We can do it in half an hour, within half an hour. But after initially it will take time, but once you do the lab, it's very easy, guys. Okay. 3.3.3 area. Next network is 192.168.23.0. Did I advertise 23.0 on R2? Yeah, it's advertised. Okay, R3 23.0 area 0. So I have configured here, and OSPF is also up. So on R2, if you see, right, now you will see two neighbors 1.1.1 and right, you will see on R2 router 1.1.1 is neighbor, 2.3.3 neighbors. So neighbors are discovered and the routes also exchanged. Can you see? Show IP route. Yes, you will see 3.3.3 route and 1.1.1 route. Let's go on 1.1.1. Check the routing table. Show IP route. You can see, right? 1.1.1, sorry, 2.2.2 is learned via OSPF. How you will come to know? It's saying O. O means here OSPF. Understood? O means it's learned via OSPF routing protocol. Now, what is the administrative distance of OSPF? 110. Right? Yesterday I told you it's 110. What is the administrative distance of static route?
1.
Very good. 1. OSPF is 110. Okay? Yeah. And what is the protocol number of OSPF? What is protocol number? See how system will come to know this is a OSPF. System will only understand zeros and ones, right? Once you configure a OSPF, the protocol number of OSPF is 88. Okay. So that will be there in IP header. In IP header, there is a field called protocol number. Okay. Tomorrow I will show you. The protocol number of OSPF is 88. Don't confuse with administrative distance and protocol number. Administrative distance is trustworthiness of the route. If you have two routes, like to reach Hyderabad to Bangalore, you have highway and you have service road. You will prefer highway, right? It means higher, lower administrative distance. The trustworthiness of the route. It means the road is good to reach the destination. There is no patches. There is no, patches on the road like that. So like that. So trustworthiness. So lower administrative distance will prefer the best path. Okay. So the AD value of OSPF is 110. Now can we ping 3.3.3? It's pinging. See, the advantage of dynamic routing protocols is you no need to add 2.2.2, 3.3.3 manually. Did I add it? Did I add 2.2.2,
No, sir.
3.3.3 manually? No. It's automatically learning,
No.
right? Which one is easy? Dynamic or static?
Dynamics.
Yeah,
Gaming.
because if you take 50 routers, you just configure OSPF and advertise your networks. That's it. You no need to advertise 50 networks. You just advertise your networks. That's it. It will learn automatically. These all are one company, right? So these all are in one domain. Simple. You guys are working in one team. There are ten members in your team. 10 members will come to know each and everything, right? Whatever the passwords, whatever the team stuff you're using, everyone knows like that. This is belongs to one OSPF protocol group. They will exchange all the information each other and they'll have the reachability. Now I said right, each and every router maintains a database. Let's see the database. This is very important. I would like to show you. All three routers having the same database. Let's see. Show IP OSPF database. Are you seeing the databases here? So what is the database here? 1.1.1, 2.2.2, 3.3.3. You will see these are types of LSAs. It will I will explain you this tomorrow with databases. But if you see right, show IP OSPF database. Same. See, this is also, let me detach this. Okay, you will see, right? Same. See, same database. Is it equal, right? Are you getting my point? See, oh, 333. Huh? Okay. This is one, and this is another one, and this is another one. Okay, let's detach this. Okay, see one database. Let's detach this. Another one, another one. Let's see. Mm, Let me put in this way. अरे बाबा ये क्या है भाई? Hmm. Okay, fine. Let's detach this as well. So show IP OSPF database here. Let me type show IP OSPF database. See R2 database, R3 database, and R1 database. All are same, right? If you see carefully. Yes or no? All are having the same database, right? 1.1.1, 2.2.2, 3.3. See, this is what? This is R2
Yes, sir.
database. See, right? Everyone is having the same database. right? Everyone is having the same database. This is called, that's why this is a link state database routing protocol. So why we creating areas? Because the disadvantage of same database, that will I explain tomorrow. But understand, all the routers in OSPF area 0 having the same database. Okay, Adi. Cool then. Now, this is area. Okay, area OSPF. Is it easy? Configuration is easy, right? Just do this. And I want to explain one more thing here. Let's configure with one more thing, wildcard mask. Okay, okay. Dynamic routing protocol. What is the AD? AD is 110, right? And what is the protocol number?
88.
88.
88. Remember this. Okay. So I'm going to give you a screenshot. I will give all this screenshot to you so that you can easily remember the things. Okay. This is a static route. I'll remove it. Okay. Now let me take one more router here quickly. Let's take a connection. Suppose 1.1.2, 1.1.1. What? Okay. Cool. Okay. Let's turn on this route. Okay. Remember, I would like to tell you one thing. So the agenda of dynamic routing protocols is you need to exchange the routes, right? What routes you are exchanging? 3.3.3. So R1 is sending 1.1.1 to R2. So R2 is sending so their routes to other routing protocols, right? So the agenda of dynamic routing protocol is you need to advertise the routes. That's it. You need to advertise the routes in the form of what? In OSPF, how exactly the routes will, who will carry these routes? Who will carry these routes? Link state advertisements. We call LSAs. Link state advertisements. Okay. Link state advertisements. Link state advertisements. It means R1 will advertise 1.1 to R2. Okay. R2 will advertise this 2.2.2 to R1. So they are advertising their routes each other. This is called link state advertisements. So LSAs. How many LSAs we have? There are a lot. Currently, today I will explain about type 1 LSA. What do you mean by type 1 LSA? It's a router LSA. It means each router will generate this type 1 LSA. Who will generate type 1 LSA? Each router in OSPF domain will generate type 1. Very important. Who will generate type 1 LSA? Each router in OSPF. Wherever you configure OSPF, the OSPF router will generate type 1 LSA. What you will see in type 1 LSA generally? Type 1 LSA, router LSA. What you will see? You will see the route. Suppose 1.1.1 is the route. And who is generating this? R1 only. So here you will see there are two fields. Link state ID. Link state ID means it's a route. Link state ID, it means the route. And the advertising router. ADV router. Advertising router in the sense, who is advertising this? Who is advertising this? R1 only, right? So the advertising router means the router ID of the router. So what do you mean by router ID? I didn't explain about router ID, right? So router ID is, it's a name. My name is Ramesh, right? It's my identification. Similarly, in routing domain, whatever the routing protocol, in routing domain, the router should have a name, right? The name is called router ID that represents in IP address. But this IP address is not a pingable thing. It's just a name. There represents the router ID in the form of IP address. It is not using anywhere to carry the data. Understood? They advertise router ID. See, router ID is just a name. They represent in IP address format. Okay? Understood everyone? Everyone understood this? Router ID is just a name. They represent in IP address format. So R1 is generating this type 1 LSA 1.1.1 route. So how router ID will elect loopback address? Whatever the highest loopback address is there, right, on the router, that will be the router ID. It means on R1 we have configured only one loopback address. That's why our 1.1.1 is the router ID. In case if you don't configure a loopback IP address, whatever the interface IP address is, right, that is a router ID. Definitely will configure the IP address on the interface. physical interface. In case if you don't use loopback, at least you will configure the IP address on the interface, right? That IP will be the router ID. Currently, what is the router ID? We have configured a loopback, right? What is the router ID? It's 1.1.1. Yes or no? Agree? Anyone having any questions?
Clear, bro.
Okay. So in this type 1 LSA, 1.1.1 is a route. But what is the advertising router ID? Advertising route means router ID. Who is generating this 1.1. Right? That router ID. So it means R1 router ID. What is the router R1 router ID? 1.1.1. That's what you see here. If you see here, right, on R1, clearly, this is router LSA. In area 0, router link state. It's a router LSA, type 1 LSA. What you are seeing, link state ID is 1.1.1 and the advertising router is this. Clear? Right? So this type 1 LSA will generated by R1 and it will send to R2 and also it will send to R3. It means the type 1 LSA is within the area. Okay? It cannot cross another area. This is another area. What area it is? Another area. Okay? What area it is? You can say area 10. Give me one number. What number of area? I can take any area. 0 to 255. Can I take 10 or 20 or please one number? Hello? Unnar
Take one
leada?
number, bro.
Take.
One.
Ah
That is
man.
zero, no?
Give it 2 digit to give 2 digit. It is too easy to remember easily.
Okay, you can take 10 now.
Okay, fine. Anyhow, this is area 10. Okay. So whatever the type 1 LSA is there, right? This type 1 LSA will be within the area. The scope of type 1 LSA is within the area. It cannot travel to the area. So R1 will generate a type 1 LSA, will give it to R2, R3. Similarly, however, how R1 is generated type 1 LSA, right? R2 will also generate a type 1 LSA, right? Each router will generate a type 1 LSA. Now tell me, what will the link state ID in R2?
It's 2.2.2.
Very good. And
Two
advertising
dot
router
two.
also,
2.2.2.
that's what you see, right?
So, bro, can we
Right?
say that advertisement router and the link ID both are same?
No, man. Yeah, no, it's not same. So advertising router is a name, router ID. Okay. So 1.1.1 is a route. So here it is showing the same because this is a route. Link state ID means the route on the link. This is the router ID, which router is generating. If you see right now, there's a 12.1. There's a 12.1 G1/0 right here. 12.1 is configured. Who is generating this LSA? 1.1.1. I'm coming to that only. Okay. So the network, this is a network. This network IP address will be anything. But who is generating is it's a name, router ID of the router. Okay. It's not a same. Understood, brother? Today
Yeah,
I
okay.
want to concentrate on type 1 LSA only. So R2 will generate a type 1 LSA and will send it to R1 or R3. And R3 also generate a type 1 LSA will send it to R1, R2, R3. So each router will generate a type 1 LSA and you will see all type 1 LSA on the all the routers. So how many routers in OSPF area 0?
3.
3. How many type 1 LSAs you will see?
3.
Yeah. Are you seeing all type 1, all 3, right?
3.
Is it clear? Everyone clear? Everyone. So
Yes,
each
sir.
router in OSPF domain generated type 1 LSAs. What do you mean by LSA? Whatever the routes, right? That routes will be advertised through LSAs, link state advertisements. Okay, clear? This is a type 1 LSA. So this type 1 LSA is this, and whatever the links, right? The links 12.0, 13, 23.0. These are the links. This is called type 2 LSAs. What we call type 2 LSAs? Type 2. It's router summary LSA. If you see right, type 2 LSS, what we see is sorry, router summary nai network link LSA. Okay, network link LSA. If you see here in PowerPoint, there are a lot of LSAs here. I'll show you here. Network LSA. This is called network LSA. Network LSA. It means this 12.0 is a network, right? So sorry, it's not a, it's type 3. So it's a network LSA. So it represents a network. So how many network you will see on here? It's a link. Network you will see on the point to point, guys. Remember, whatever the links are there, right? In each link, you will see the type 2 LSA. Okay. So how many type 2 LSAs you will see on router? Router 1? Only one. So one network is there, physical network 12.0, not the loopback. Okay, 12.0, because 1.1.1 is already advertising through type 1. It's already there. So this link router, link, right? The IP network on the link will be advertised. It's 192.168.12.0 will advertise by 1.1.1. Okay, this is called type 2. So type 2 LSS. Clear? So type 2 LSS. How many links are there here? Two links. That's why two network LSS you will see. See here, two network LSS you will see. Yes or no? Hello? There are two networks here. That's why you are seeing two network LSS. Yes or no? Hello?
Yes, sir. Yes.
Yes, sir.
Yeah.
12.1, 13.
So this type 1 and type 2. Tomorrow I'm going to explain about type 2 very deeply. Okay, you will understand that. Whatever, just I'm giving a brief about type 2, just network LSS networks. So whatever the type 1, type 2 LSS are, these are within the area. These type 1, type 2 cannot cross other areas. You cannot see this type 1 LSS here. So if you cannot see, what is the problem here? You cannot ping 1.1.1. So if the router is connecting with two areas, that router is called ABR, area border router. So here it is a ABR router. R3 is connecting with area 0 as well as area 10, right? That's why R3 we call as a area border router, because it is connecting with two areas. So what ABR will do? This type 1, type 2 LSS cannot cross the area, other area. So what ABR will do? Whatever the information it is there, right? All type 1 and type 2, that will convert as a type 3. It's called network summary LSA, and they will put in same thing 1.1.1 network and 192.168.12.0 network. Okay. So these networks, what it will do? Whatever the type 1, type 2 LSAs in area 0, that will convert into type 3. Type 3. Okay, that will convert into type 3 LSA. So who will generate this type 3 LSA? ABR. Now what is the advertising router here?
Router 3.
What is that? Tell me.
It's 1.1.1.
Router 3. So what do you mean by advertising router?
Sorry. 3.3.3.
Yes, router ID of,
3.3.3.
yes, who is generating this? 3.3.3. So whatever the, so how many type 3 LSS you will see here? So total how many type 1, type 2? There are 3 type 1, 2 type 2. Total 5 LSS, right? There are 3 type 1, 2 type 2. Total 5 LSAs will convert into type 3. You will see 5 type 3 LSAs on R4. Okay. Can we configure and quickly verify it? Hello?
Yes, sir.
Yes, bro.
Yeah, just 2 minutes, it will be finished. Okay. Arey Baba, what is this? Okay. So let's do that. Okay. Okay. R3 configure terminal. What is that interface? G1/0. What is it? Interface G1/0. IP address 192.168. It's 34, right? 34.3 I
Mm.
can consider. Okay. 0, no shutdown. And now I need to configure OSPF. Let's configure it. Now tell me, router OSPF area, router OSPF 10 and network. What is the network? It is 192.168.34.0 network. Okay. And the wildcard mask. And tell me what area I need to give here.
10 area.
Very good. Area 10. Everyone understood this,
10.
right? So this 34 dot network, 192.168.34 dot network is belongs to area 10, right?
Yes, sir. Area 10.
192.168.34.10. This belongs to area 10. That's why you need to give area 10. Okay, that's it. Only one command. That's it. Remaining already advertised into area 0. Let's configure on R4. So R4. So configure terminal interface G1 slash 0 IP address 192.168.34.4 255.255.255.0 no shared interface. Next, IP address. What is that? 4.4.4.4. Okay. Uh, 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 that's it. Now router OSPF 10. Okay. Now network. What is the network? 192.168.34.10. Wildcard mask area. What is the area? 10. Next network 4.4.4.4 area 10. Now I have configured area. So let's see here. Show IP OSPF neighbor. So neighbors are established. Now you will see. I said right. Total all type. How many type 1 LSS here? 3. Type 2 LSS are 2. Total 5 LSS you will see in type 3. R3 will convert this type 1, type 2 into type 3 and it will put here. Can you check the database? Show IP OSPF database. Are you seeing this? All type 1, type 2, right? This is R4, right? Let's take R1. Let's detach R1. Okay. This is R1. See, R1, type 1, type 2 LSS, you will see in summary LSA type 3. Yes or no, right? 1.1.1, 2.2.2, 3.3.3, 12.0 network, 23.0 entire network. So, who will generate type 3 LSA? Who will generate type 3 LSA?
ABR.
So that's why we'll see ABR router ID here. We are seeing ABR router ID, right? Everyone, whatever we discuss theoretically, we are also seeing here practically. Yes or no?
Yes, sir. All are converted to
Yeah, all are
3.3.
converted, and this you can see proof as this ABR is generating, right? That's why it is converting 3.3.3. That's it. So what we have done today, we have configured OSPF within a single area and multi-area. Also, we cover type 1, type 2, type 3 LSAs. So type 2 LSA tomorrow I will discuss clearly during OSPF adjacency process. Okay. So today what we have discussed? Today we have discussed dynamic routing protocols, how exactly it will behave. Okay. Today we have discussed dynamic routing protocols. Okay. What is this? And how exactly it works? What are the dynamic routing protocols based on EGP, IGP? And IGP I have discussed OSPF and the configuration multi-area. You can just verify this. Bro, please go on mute. I'm getting noise. Okay. So please download this. Bro, please go on mute. Who is there? Okay, thank you. So download this PPT. I build a lab. I given a configuration. If in case if you need any configuration also, so please download this PPT and configure it clearly. Okay. So tomorrow I'm going to discuss about OSPF adjacency process, which is very important to become a professional network engineer. Today I'm going to give a task. If you want to understand tomorrow class, you need to do this thing. What you need to do? Please, we have each and every protocol will have a packets and header. We are talking about OSPF, so we will see OSPF header like IP header, right? Like that OSPF header and OSPF packets. Please by heart this. This is the OSPF header. What are the fields inside the header? Everyone must and should tell me tomorrow. Okay, router ID, area ID. There are a lot of things. Important fields. These are the important fields. So you need to prepare OSPF header and hello packet. This is the hello packet, and then DBD packet. This is a DBD packet. Okay, with clear explanation I have done that. You don't need, if you don't have time, don't read it. Just by heart these diagrams. What are the fields inside it? And you today we learn link state database. You see link state request, link state ID advertising router. Today you learn this this link state packet header, but tomorrow you need to prepare these three headers. What is that? OSPF header and hello packet header and DBD packet header. Please prepare these three packets header before joining tomorrow class. Okay, very important. If you prepare well, tomorrow you will understand easily. So tomorrow I will ask you during the adjacency process, it means to build a neighborship, what are the states? What packets it will exchange? So if you learn at packet level, you are the master of OSPF. You can easily troubleshoot each and everything. So please prepare headers. OSPF protocol header, these are the fields. Hello packet header, these are the fields. And DPD packet header, these are the fields. Just 20 minutes, spend 20 minutes, become the pro network engineer. I'm challenging you. Even 10 years of experience candidate cannot resolve the issues. If you learn this, you are the pro network engineer. I want to create everyone as a pro network engineer. So please do this stuff to me. Okay. Prepare these headers. Tomorrow I will explain again and you will be master in OSPF. Okay. Understood? So this is the task I'm giving to you today. Prepare packet header fields. Practice it carefully. So if you see right here, download this PPT. Remember this important fields at least. In OSPF header, you will see version, router ID, area ID, authentication type and data. And then this is network mask. You will see network mask, intervals, and DR, BDR. So this information, just practice it. Okay. Yeah. That's all for today. Any questions? Any questions? If you have any questions, please ask me.
బ్రో అది వైల్డ్
Yeah.
కార్డ్ మాస్క్ ఇస్తున్నాం కదా, అది
అవునవును.
ఒక్కసారి చెప్తారా కొంచెం?
So wildcard mask means this is a wildcard mask, right? So wildcard mask is what is the total subnet mask? It's 255, 255, 255, 255, right? Total subnet mask generally, right?
ఎస్.
Yeah. So what is the actual subnet mask? You are taking this network. This is a classy network, right? What is a classy network subnet mask? This is. So remove this actual subnet mask from total subnet mask, and then you will see 255, 255, 0, 255, 255, 0, 255, 0, and you will see 255, right? Why we are using this wildcard mask? You are precisely matching the last bits, not these bits. 0, last bits. Clear? So for in efficient way, we are matching the precise bits. For that, we are using wildcard mask. It's a syntax. Clear, brother? Still having questions?
నో బ్రో, క్లియర్ క్లియర్.
Yeah. Okay, na? So can I share this screenshot to you? It's
ఎస్ ఎస్ ప్లీజ్.
yeah. So please practice it and yeah. Any questions? Any questions before going to stop the recording? Any questions? So today we learned a lot. Okay. So please prepare it well and do the labs and prepare the headers for tomorrow class. Thank you.